Thanks again for joining us for today's webinars on MEAPA. We have around 140 guests registered for this event and joining us from all around the world. I see people joining from the Middle East, Europe, Latin America, and of course the US. So a big thank you for all of you for joining us. Before I introduce our speaker, I would like to cover a few housekeeping topics. First of all, you can find these slides on the MEAPA website. The link is the one written over there in this website, in this slide, sorry, is the same link you got in the email for the invitation to today's webinar, but you will see the same link other times throughout the presentation and also at the very end of the presentation. This webinar is being recorded, so we will be able to share a link with you after the event is complete. We welcome you to, of course, revisit the video yourself and its content, and eventually share the video with your colleagues. Also, we would like to hear from you, so feel free to submit questions for our Q&A session at the end of the presentation. On the bottom side of the Zoom window, you should be able to see the Q&A icon. Just click on that icon, type your questions, and then I will pose your question at the end of the presentation to our speaker. Now, if you don't mind, I would like to ask you a few questions. So we want to engage you in a quick poll. You should be able to see on your screen a window with a few questions. Just for us to understand how familiar are you with the mechanistic empirical payment design concepts, and which method of payment design is currently used in your state and country. So I'm gonna give you a minute just to fill in these two questions, and then we'll continue. Okay, so I guess we got your responses. I still see some of the attendees joining right now. So it seems that the majority of you are very familiar with the mechanistic empirical payment design methodology, which is a good thing. Now I want to continue with the webinar by telling you what are the objectives of this webinar. First of all, we would like to introduce MEAPA and some of its features, and of course provide a quick user guide. Even though we welcome technical questions for the last portion of this webinar for the Q&A session, please be aware of the fact that a different webinar, more on the technical contents of MEAPA and some example of payment design using MEAPA will be offered later on. So this is just to provide a quick introduction and a user guide for this new software. So what is MEAPA? MEAPA stands for Mechanistic Empirical Asphalt Payment Analysis. It is a new web-based payment design application which includes all the concepts behind the so-called MEPDG, Mechanistic Empirical Payment Design Guide. Since it's a web-based payment design application, you can access this application from any browser. Google Chrome is recommended, but I personally use Safari with no problem at all. Again, since it's a web-based payment design application, you can access the website from your computer, of course, from your smartphone, and from your tablet or any other handheld device. No installation is required because everything is online. You can download the data at the end of the analysis, as Dr. Kutay is going to show you. But in any case, all the data are saved in the cloud. So you don't have to download the data if you don't need to. I have been using this software for quite a bit of time now, and I personally enjoy using it. The best thing for me, since I'm not based in the US, I'm based in the UAE, is the fact that one of the features of this web-based design application includes also already some climatic station all around the world. Here in this picture, you can see one climatic station in Saudi Arabia, one in the UAE, where I'm located, and one in Qatar, but there are many others all around the world. So this is fantastic for me, and I have been enjoying a lot using it so far. Today's presenter is Dr. Amin Kutai. Seems that, okay, now it goes. Is Dr. Amin Kutai. He's a professor at Michigan State University in the Department of Civil and Environmental Engineering. Dr. Kutay's expertise, among others, are material characterization, design and modeling, pavement design and analysis. And without any further ado, I will leave the floor to Dr. Kutay. It's all yours.
All right. Thank you, Mike. So thanks for the very nice introduction. Before I start with the content of the webinar, I have to say that we were pleasantly surprised with the interest. So we all appreciate you coming here and taking time during the summer to listen to us on this new application. Now I'm going to get to the slides. So how to access this application? Registration is quite easy. If you go to the main website, if you click on the sign up icon, you will see that we have two different versions. One is the community free version. The other one is the professional version. Both of them are almost identical with only three different limitations on the free version. One of them is the analysis period limitation in the free version, which is 5 years. And for the other limitations are you can only create one project in the free version, and you cannot upload or download the project. So this is great for educational purposes. If you want to try out, 5 years should be plenty. All the other features are all there. All the climatic stations are there. Everything else is there. So all the things that I discuss in today's webinar is going to be there. Now, once you register, you will see the login page, and you're going to enter your username and password. It's pretty straightforward. Once you get through the login, this is what you are going to see. You're going to see a screen. This is the project detail page, what we call. And in this screen, a lot of the items are frozen because we haven't loaded a project yet. One thing that I'd like to strongly encourage is, before you go through doing anything, is going through the video tutorials. So video tutorials include a lot more details. Although today I will be discussing a lot of the details on how to use MEAPA, but tutorials will be certainly very helpful. And the documentation, and there's a PDF that includes all the equations and how the models are implemented. So technical details are going to be in this PDF. If you have any questions, you will see a feedback icon here. Make sure that you click on feedback. You can provide a feedback, obviously, and also ask questions, and they will be answered promptly. Now, the place that we start is right here. So first thing we do is we click on project. And when you click there, you will see three options. These three options are open, new, and upload. The upload is not going to be there in the free version, but the professional version will be there. So if you already downloaded earlier, you can upload your old project from your computer. So when you click new, essentially you're going to enter a project name. Once you enter a project name, you're going to get to the project detail page. So the project detail page, the first page, includes the basic pavement analysis or design inputs. The first one is the average annual daily truck traffic. The other one is the directional distribution, lane distribution. I'm assuming from the poll, I can see that your audience is quite familiar with the general pavement design concepts and also in ME. So these are kind of self-explanatory. And also vehicle speed and ground motor table, as well as the traffic opening month and year, are entered here. The second thing that are entered in this page is the climate, a climatic station. So on the right side, there is a map. It's a Google map. Essentially, by zooming in and out and panning using the wheel of your mouse, you can easily go around and find your location. You can also search by city and then click. So I'm going to actually, at this point, I'm going to go to the main, our website and then do that just to show you. Let's start a new project, I-75. And this is the project detail page. You can see I'm just zooming in to a place of my choice. Let's say this is let's I-75 is what I'd like to design. So just one click and save. Once you saved, you can zoom in and out, and it will find the closest climatic station automatically. And it will show you the latitude and longitude of the closest climatic station. So let's go back to our slides. Now, another feature is obviously the Google's feature is the street view. If you're interested in seeing how the road looks like based on the latest picture taken by Google, you can just use this and then look around and how the picture is looking. If there's any interest. So once we do that, we can change the climatic database. In MEAPA, 2 climatic data is already included. One is NAR and the other is MERA2. So you can go to advanced coefficients here and change the climatic database. So when you click advanced coefficients, you will go to this page. I'm going to do that live here, advanced coefficients. And if you look at here, there are 2 different options. You can switch to MERA2 and you can save. And when you go back to project detail page, it will automatically update and find the closest MERA2 station, and it will use the MERA2 data instead of the NAR data in this particular case. So that is how to find the location and climatic station. The next step is having a pavement profile. So once you start a new project actually comes with a default pavement structure. And this pavement structure, let's go back to the website. If you click the pavement profile, when you click a new, it already comes with a big structure, thick structure that includes pretty much all the possible layers. This is an overlay with a chemically stabilized material. We thought it would be easier to delete layers than adding them. So let's say if you are interested in just a traditional design, click on the layer that you want to remove. And this is existing AC and chemically stabilized material. I'm removing them. So all I'm left right now is an asphalt, a 4-inch asphalt over a base layer, over a subgrade. That's very typical, maybe a local road. So now you can see the layer structure is here, and I removed by clicking at minus here. You can add by clicking at plus here. So if I want to add another asphalt layer, let's say, you can put, this is just any name that you can put in. Let's say we can put in a 5822 binder. So it automatically added on the top of the AC layer. So, it automatically adds on the top of the type of pavement. So not necessarily where you click. So let's say I'm already clicked here. And if I want to add a base layer, I have existing AC, EAC, CSM is chemically stabilized material, and base layers. If I click on base layer, let's say base 2, create layer, it will add that on the top of the whatever the base layer that exists there. And you can move up and down very easily here, and this saving is automatically enabled, so you don't have to there's no separate save button. Once you move up, and it's automatically saved in the MySQL database, by the way. Now let's go back to the slides. Now, once we have all the layers that we want, you can click any of these layers. And once you click any of these layers, the input boxes located at the lower part of the page shows the properties of each layer. For example, if I click on a C layer, if I go down here, these are the properties. You will see the name of the AC layer here. So that's how you know which layer you are looking into. If you go to base, you'll see this is going to show as base. So this is AC, and this is the standard properties like thickness, unit air voids, effective binder content, and all that. Of course, for AC, we have the dynamic modulus master curve, and phase angle needs to be entered here, and the binder shear modulus here. So we will talk about that in a minute. Now, the one thing we did is we wanted to put a quick summary of all the properties on the top. So what you're seeing on the right side of these layers is the most important, perhaps, inputs that actually fits there. So you will see for AC layer, the thickness, air voids, and effective binder content by volume are shown here for an existing AC, similar inputs, and also AC condition. For CSM layer, we will talk about that in a minute. Thickness and maximum minimum modulus are there. Now, let's go to the AC layer. Now, one of the things about this is if you see any table, any of the tables you see in any of the links, when you see 3 dots on the upper right corner, that means there is something you can do with those. So when you click there, for example, for this particular table, when you click there, there are like 5 different options you can do. You can copy this table and paste into an Excel sheet. I'll show you that in a minute. Or you can take the data from an Excel sheet and paste into here. And you can enter E-style master curve coefficients that will, if you already have the coefficients, but not the data themselves, you can enter them here. And you can select an E-star from the database that exists here, and you can edit frequencies and temperatures shown in here. Essentially, all the actions that can be taken is shown right here. Now let's talk about copying entire table. So once you do that, let's do that really quickly here. So let's say we are an AC layer. I want to go down, and let's say I want to copy this. So just copy entire table. Now the table is copied. So what I will do is I'm going to create a new Excel sheet, and just Control V or Command V. It's saved here. All you have to do is you can edit this. Let's make this, instead of 4.8, make it 8. And you'll have to just select this, copy, go back, and paste entire table, Command V, done. And you can see 8 showed up here, and then click Save. So copy pasting is useful. So this is what we recommend, instead of trying to type in here, you can type, you can change them here, but it's probably easy to work on an Excel sheet and paste it back here. Now, other options are obviously entering an E-star master curve coefficient. So in this case, when you click there, you will see that there is an equation, there's a set of equations. So your E-star master curve needs to be developed using these equations. These are common equations, but needs to be follow these equations. This is the shift factor, this is the sigmoidal. So you need to enter the coefficients by entering the A1, A2 reference temperature, B1, B2, B3, B4, which are shown here. D1, D2, D3 are the coefficients of the phase angle. And when you click calculate, it will automatically populate the table in the background. So another feature is selection of E-star from an embedded database inside the MEAPA. So when you click there, you will see a whole bunch of data. Now I'll do that live here. So let's go and click on E-star, select E-star from the database. You can see there are a lot of mixtures. These are based on all the mixtures that has been that was available to us, that has been tested. These are actually real mixtures. Those mixtures collected from the field with different PGs and different nominal maximum aggregate sizes. So what you're seeing here is, let's say, if I'm talking about, let's say, 9.5, 6428, that means that this is a nominal maximum aggregate size of 9.5 millimeters and with a PG, a binder PG of 64 and 28. And this was measured in Michigan, United States. You can see right now they're all from Michigan, United States, because we tested them. But we are certainly open. If anybody is interested in sharing, we can put all the data here for everybody's use. So when you click load here, you'll see it will load that data here. It will show in a different color, and you need to click save that so that it is saved in the software. Let's go back to the slides. That's what this slide is showing. It's saved here, and we are done. Now, one thing that I'd like to mention is, as you can see, there is phase angle that needs to be entered here. E-star master curve is generated and it's used everywhere throughout the software. Phase angle, though, is only used in the thermal cracking model. So, you know, the way that it works is that we decided not to have the creep compliance master curve as an input for thermal cracking. We decided to convert the E-star master curve to relaxation modulus master curve, which is used in the thermal cracking model to calculate the thermal stresses. So that kind of eliminates the need for creep compliance. But downside is obviously you have to enter the phase angle. So obviously most devices measure both phase angle and E-star. But if you don't have it, let's say for whatever reason, phase angle, you just don't have it, the only thing that is affected is the thermal cracking model. All the other models are not going to be affected. Fatigue, bottom up, top down, rutting, they are not affected at all. So I just want to make that note here. Now, lastly, if you want to edit the number of frequencies and their magnitudes, you just click here, and then you can do that by clicking that and just enter the frequencies separated by comma and the temperatures separated by comma. Click save. I will do that really quickly just to show. And edit frequencies. Let's say these are the frequencies that I want to enter, and these are the temperatures I want to enter. Click save, and automatically the table is edited. And you will see when you do that, the table becomes all, the data is all cleared, so that you know, you enter them, you don't use the old data. So all you have to do is just either re-enter, or you can go back to the database and select the same mix, let's say, or other mix, and save, and then you'll have the data there. Now let's go to the binder. Binder GStar is only used in the global aging system model, gas model. So it is not used in generation of the master curve. So in the original MEPDG documentation, dynamic modulus master curve is also is based on some information from GStar, but here we don't do that. So if you don't have binder GStar, it's fine. It'll just, the gas model is going to be turned off. But you know, we have a database for that also. So for some binders, the measured GStar master curve. So you can click there and you can load the typical GStars of some of the binders. We don't have all of them, but we are hoping to improve this database. In the future, you can click any of the binder and your GStar will be updated. So for example, here, select GStar from the database 7022P. It's updated here and we click save, and then we get the data loaded up. Now, next, I'd like to talk about the existing AC for an overlay design. So existing AC, EAC layer, that's what it stands for. EAC layer is exactly the same as a typical AC layer, except no binder data is entered. So as a result, no aging is used in there. And also damaged E-star is computed based on the damage level entered. So the damage level, these are the typical damage levels that we recommend entering, depending on the condition of the existing AC. So once you enter that, and also once you enter the E-star data, which is like an undamaged state, because of the damage, MEPDG concepts are used to calculate the damaged E-star for the existing AC layer. Now, this is one just snapshot. I know I promised not to show any equations, but just to show you, let's just zoom in a little bit, how to calculate the E-star based on the damage inside the existing AC layer. So this is the equation we used. So that's in the documentation page. So I recommend you to take a look at it. Now, for the chemically stabilized material, most important inputs are minimum maximum modulus and the strength or flexural strength. Chemically stabilized material could be a cement stabilized material, lime stabilized material, any stabilization. But these are the inputs that are needed. And here's another equation. I just want to highlight that for that particular layer, the damage is calculated inside the chemically stabilized material based on a damage model that is listed in the documentation. And the modulus with time actually decreases depending on the damage accumulates inside the chemically stabilized material. Now, for unbound materials, it's quite a simple layer. It's just simple elastic assumption. Resilient modulus is entered, and everything is based on the layered elastic model. Now, I'd like to note that we are working and we are getting very close into putting an isotropic nonlinear layered model here so that we can enter the actual K theta or K1, K2, K3, K theta tau model into here, and that is going to be implemented quite soon. We are working towards the validation through a finite element, and hopefully this is going to be added along with the GeoGrid implementation based on the latest NCHRP research. Now, a subgrade layer is quite simple, just the resilient modulus, and a couple of other information you need is the percent passing, number 4 and number 200 sieve. These are important for the IRI and all that. Now, another page is the vehicle class distribution. So the vehicle class distribution, the classes are based on 10 FHWA classes, and the percentage of each class are entered here, the growth type, whether it's a compound or linear. And also on the right side, you have the number of single axles, tandem axles, and tridem and quad axles for each type of class. They're all entered here. As you can see, 3 dots are available here as well, which you can copy and paste into an Excel sheet and take it back and paste it here. So you can work in an Excel sheet, or you can edit right here as well. Monthly distribution factors are also here. Again, you can copy and paste data into an Excel sheet, and then you can work through this. So if you have done any MEPDG calibration or input in your state, those data can directly be used in here. Now, for the axle load spectra, it's the same exact thing. So for single, tandem, tridem, and quad axles, so for each load level, for each class, and for each month, the data is entered here. Again, we recommend copying and pasting the data from an Excel sheet. It's very hard to work in here, but if you are making few changes here, it's fine. You can make changes and save here. Again, if there has been any traffic characterization study in your state for MAPDG, you can directly use those as input here. These are just few output snapshots of the plots of the Excel layout spectra. Once you get a PDF out of the PDF report, these are what you're going to see and in the PDF report. Now, a couple of technical concepts that I just wanted to lay down just to show on how everything works here. So when you have, let's say, 10 different FHWA classes that you entered into the vehicle class distribution, and then you entered the Excel load spectra, what happens inside the software is, like in MAPDG, everything is converted into 4 big matrices. So a number of single Excel repetitions, that's right here, for each month, for each wait period, and for each year, for each year. Now, the same thing is the number of tandem axles, number of tridem, number of quad axles as well. And what you're seeing here is the actual analysis points that are calculated from the layered elastic algorithm. So this is just one simple example of a sublayering of a 3-layer structure and how sublayering is done in MEAPA. And this is a dual tire single axle, and these are all the data points where the structural responses are calculated. Inside the MEAPA, we have the MATLIA software, which is a layered elastic analysis software that was written in MATLAB in here. So we use that in structural analysis. So I'm going to move to the going back to the MEAPA, the software tutorial here. Advanced coefficients page includes the calibration coefficients like beta 1, beta 2, beta 3, for example, K1, K2, K3, and transfer function, and all these are in advanced coefficients here. So one thing that I'd like to highlight is there's a little question mark on the upper right corner of each of these boxes. I strongly encourage you to click that, and when you click any of them, you will see a summary page for each of the models. So for example, for bottom-up cracking model, what are the main key equations in that bottom-up cracking model? It's not just a copy paste of the documentation, just the key equations compressed into one page, just so that you can see which one of those beta 1, beta 2, and beta 3 are, or C1, C2, C3 are essentially. So a very quick snapshot of the models themselves are in each of those advanced coefficients. So let's go here, advanced coefficients. You can see if you click here, it'll show up you can zoom in to see how the equations look like. Let's say beta 1, beta 2, and beta 3 here. So you enter the values here accordingly. So what you're seeing here is the bottom of fatigue cracking standard deviation equation. You also need to enter in this format, exactly in this format. You can change the coefficients, but you should enter in this format such that only exponential, log 10, and bottom are used in your equation. So let's go back to one other feature that I'd like to talk about is we have a revised climatic model as an option, which is essentially correcting for cloud cover factor on long wave radiation. We have details on the documentation. I don't want to get into too many details, but there is an original model that was as implemented in MAPDG, but there is also an improved model, which is proven to be more accurate model there, which you can choose to use. Again, it's a choice. It's right here. Now, the stresses computed by MEAPA includes top-down. So we have a list here. So I'm not going to go through one by one, all of them here. But so what we have is depending on the type of pavement, and these are essentially 6 different types of pavements that can be analyzed, and these are all the distresses that comes out of these. So this is just for documentation purposes. ACGB essentially is asphalt concrete over gravel base. You can have multiple ACs and multiple GBs, but this is just a simple traditional structure. AC over chemically stabilized material, for example. AC over an existing AC. So this is like an overlay design, and so on and so forth. Now, when we click Analyze right here, Analyze button, let's go back here and click on Analyze button right here. So when you click Run Analysis, you will see that this analysis will start. There are two inputs here. They are not very important. One of them is distress save period. So how often you should save the distress while it is running. 1 month is pretty much okay. Structural response save period is kind of important, and I'd like to emphasize here. If you don't need structural responses, put a large number here. If you do need structural responses, meaning that, let's say if you're doing a research or for other purposes, you want to have the entire structural response of all points that I showed earlier in the structure, points, the stresses and strains and everything for the whole duration of the analysis, you can get that and you can see that. So in that case, in this case, I said, I don't need much, so every 240 months, so it's going to save only like essentially once at the end of 20 years analysis in this case. When you click Run Analysis, you will see the analysis will start, and then you will see an update here. One thing is, as the analysis runs, you will see the graphs shown here. So we have a method called WebSocket, where we are sending to the client's computer how as the run progresses. Now, one thing that I'd like to show is some browsers, for some users, may not, because of the security settings, this may not automatically work. So in that particular case, we have a little manual update button. So we are using actually a separate method called Ajax. We're using that to manually retrieve the update. So if in case this is running, let's say, but you're not seeing anything on your screen, just click manual update and it will show. And you can click manual update as many as you like while it is running, and it will update, it will show, okay? So one thing I'd like to mention is no news is good news, meaning that if you are not getting a pop-up saying that, oh, the analysis cannot be started, that means it's running in the background, even though it's not saying anything. So if you want to stop the analysis, you can just click on this little stop button and the analysis will be stopped. Now, at the end, what you're seeing is the distress is calculated at 50% reliability. If you want to calculate at different reliability levels, you click there and you will see automatically a default reliability table. So I'm going to go there by clicking edit reliability here. You can, we haven't run this yet. So let's see, project detail. I'm going to run this only for 5 years so that it doesn't take too much time. So let's go back here and start talking about this. So you will actually see, I'm running this, as you can see, as you run, it shows, by the way, it shows the ESL's equivalent based on the traffic here. This is calculated right at the top. It's based on the ASH293 method, based on the X load spectra and everything. So if you're interested in what ESL was this, the data that you entered is right at the top. So it's running right now. It's calculating the structural responses at the moment. It will start updating this table pretty soon once this first part is done. So let it go, and it also shows the for each month some update. As you can see, it is actually running. It's showing the calculating the stresses as it goes along. So let it go and let it finish later on. So once it is done, you can edit the reliability values or the threshold values here, and you will see the calculations will be done. And once you save, the table will show up right here. Oops, I went too fast. I think a table will show up here, and then that will include all the values at reliability or at 50% reliability. So this is almost done. I'd like to show you very quickly. Okay, so this is done. Now, okay, so let me go back. here. So, oops, I'm, I'm using the wheel of my mouse, which I shouldn't. So once you get the data out here, one of the things that you can do is you can click on the download PDF report. And once you do that, you're gonna see a PDF report downloaded, and it includes all the details of the run, inputs and outputs. And this is actually an example. And this is kind of an optimized based on the top-down cracking model. You can see this is the threshold, and at the end of 20 years, it actually achieves the design, and all the others are below the thresholds. Now, if you are interested in plotting the distresses after the fact, you click there and you'll see these plots. And if you're interested in downloading the input-output data as a bunch of folders, you click here. This download is different than the project download. When you download a project, you will see that the project is going to be a JSON file. It's a special text file that includes all the details inside. That's the input. But when you download here, input-output data, it's not a JSON file, it's a zip file. Once you unzip it, you will see a whole bunch of subfolders. This is really the outputs of all the runs and all the details. They're essentially intermediate outputs, and damage response and all the fatigue, cracking, rutting, everything will be in this folder. They're all text files, so it's very easy to load and read them. At some point, we will be uploading some post-processing tools to the MEAPA, and some MATLAB codes where you can plot and generate graphs like I showed earlier for the MATLIA. We will do that very soon and hopefully be useful, especially for students in the future. So we have another option here for optimization of the thickness. You can click there, and once you click there, you will see this table, which is the reliability and terminal distresses, or the thresholds here. And here, what you need to do is you need to select whether you want to include or not include in the design or in your optimization. So for example, in here, I don't want to include the terminal cracking because I know the thickness doesn't have much to do with the thickness of the terminal cracking, that is. So if you want to include, whatever you want to include, you include here essentially. And here, there's a drop-down menu. You will select which thickness and the information about that, which layer that you want to optimize. So here we have the asphalt concrete layer. It's shown that this is the type of layer in parentheses, and then brackets shows the existing thickness. So you need to enter minimum and maximum thicknesses that you wanted to try, and the interval of thickness. So if it is like 4 here, it will try 4, 5, and 6 inch thicknesses, and it will run MEAPA many times and see if it reaches any of these thresholds. If it is too much, it reduces the thickness. If it's too little, it goes higher, kind of a thing. And as it runs, you will also see the trial thicknesses here and also run here. So I guess that's it. So it's 11:44. One thing that I'd like to mention is there's a feedback form, and that feedback form is very important for us as you try the software, as you run it. If you face any problems, please enter your information and then your feedback. If you want any features added or removed, so make sure that you enter them, and will be responded promptly. I guess that will be the end of this, and I'm gonna pass the torch to Mike.
Thank you so much, Dr. Kutay. Great presentation, very impressive. So we do have some questions from the audience, and I'd like to ask everybody to submit their question in the Q&A chat box here in Zoom. I would like to start with a question regarding the reliability that you mentioned. So it's my understanding that you don't need to run again the same analysis if you do change the reliability. You just change the number. Reliability at the beginning is calculated for 50%. Then if you want 75, 80, 90, whatever, you just change the reliability number and the software automatically change or gives back the results. Is that correct?
Yes, yes. As you probably know, the reliability, once you enter reliability of, let's say, 90%. So what MEAPA does, it does the same thing what MEPVG does. Essentially, it shifts the stress data upwards by a certain amount. And that amount is based on the standard deviation equation, which is entered in advanced coefficients. So, for that shifting, you don't need to rerun the software, because once that's a simple equation. It's all based on the 50% reliability or whatever is already MEPA producing. So once all you have to do is just edit the, let's say here, let's go back here, reliability page right here. Okay. So once you edit any of these, and when you click save, it will automatically update this in few seconds. And you will have values at different reliability values, because it's just simple shift. It's a simple shift, but it is an important shift. But I don't want to, when I say simple, I don't want to downplay it, because reliability, as you know, it's all based on the variability along the road. And if you have data, so your standard deviation equation should reflect that, and that is an important input. It's not simple input, but
Correct. That's great. Thanks. Here we have now questions are coming. I see. I'm gonna as a reminder for everybody, this session is being recorded. So we'll send the link to download the video, the record of this session, so you can check all the details again as long as you want. A question, is there any option to change or upload gross vehicle weights considering empty or full weight of vehicles in traffic data?
Let's see. The gross vehicle weights the columns themselves are fixed. It's so the axle load spectra is in a table. So the columns are fixed, so you cannot change the columns. Like let's say for a single axle, it's 3 kips or 6 kips and all that. But having said that, you may not be able to enter exactly the gross vehicle weight that you want, but there are ways of doing that. There are ways of entering the gross vehicle weight that you have into the axle load spectra. That's why we have such a big table. There are you can generate your own axle load spectra that reflects the gross vehicle weight distribution that you have. Let's say if you have a single truck that you want to if you want to simulate, just a single truck with a certain, let's say 18,500 kips, that doesn't exist there. So you can make all the others. Okay, let's go to axle load here. So let's say we are here, and you're interested in a single vehicle with 18,500 kips that doesn't have in here. So you can zero out all the others, okay? And you can put percentages, let's say 50% of 18,000 and 50% and 19,000 in one of the classes, and make all the others zero, and it will automatically make it that it will be 18,500. And also in the vehicle class distribution page, make sure that this is 100, whatever the one class that you're talking about, and make all the others zero. So there are ways of entering that particular information, and you can make the simulations that way.
Okay, that's very good, and I'm glad you just mentioned this particular particular example because many in the audience are asking if there are any examples ready to be shown to students or professionals in their group. My understanding, and correct me if I'm wrong, is that at the moment there are video tutorials, and these are all available for all those who sign in for using the MEAPA software. And in any case, as we mentioned at the beginning of this session, an hands-on session webinar is going to be offered soon, right?
That's a very good point, and I appreciate that question. I will be teaching my class this fall also. I will need those examples anyway. So as I prepare these examples, I am planning to put them in here. For example, let me give you one example. I'm interested in simulating simply easels. And I want to put, we discussed this with you, put 0 here and 0 in all of them. And then, and I'm interested in putting 18 kips on the axle load spectra here, put 18 kips 100% and 0 everywhere else. That would be a perfect example of if you're only interested in just simulating like an easel, right? 18 kip single axle, sometimes that's useful for educational reasons. Or, if you don't have axle load spectra and if you want to simulate easels only, that works quite well. So that's just one example, which I will be probably using in my class. The answer is long answer is yes. We will provide some examples, but when we have the next webinar on the examples, hopefully, if you attend there and the students can attend there, that will be good.
Okay, that's great. With the next question, I'm gonna put together a few questions we actually received from the attendees. Is there any study on including geosynthetic in pavement profiles for MEAPA analysis? And I'm saying that I'm putting together many other questions because in the website for the MEAPA software, I also saw different upcoming softwares or features. So can you tell us a little bit more about that?
Yeah, that's a very good question. Also, now we have been working on this for a while to add a geosynthetic reinforced base layer. Mostly geogrid reinforced, and we've been working at least maybe last 2 years to come up with a technically logical and viable and also practical. So we have to do this. So we are very close. Actually, we do have the engine prepared and it's running and we're validating right now. It's based on the NCHRP, latest NCHRP project by Bob Litton, including geosynthetics in pavements. So we have already developed a cross anisotropic, actual transversely anisotropic layered elastic model that includes a geogrids in it. So we are working on final touches of the validation. So the engine is there. The only side is implementing into MEAPA, which by itself, we learned that it is a bit challenging. So we're working on that one. But it will be a feature that will be added very soon. And when it comes to other software, there are under not MEAPA, but pvaps.com, there are several software that we are going to make it available. Like Matlia, for example, is already freely available. Anybody who's interested in getting the Matlia, the layered elastic code, not the source code, but the executable, you can have it freely available. We will put an online version there soon, but there are other software coming up. And also any contributions are welcome.
Very good, very good. Now, there is another question. Can we download your documentation in PDF? I guess so. If you click on download directly on the website, you are able to download it in PDF. As Dr. Kutay is showing you there, there is an icon on the top right of the window so that you can download and read it whenever you want. And there is a question from a friend. Can we use a user-defined climate data because I'm more interested in isothermal analysis? So I'm gonna try to respond to this question. The way it worked in the past months is that, for example, I developed the Excel file for the UAE, for the climate data for UAE. I sent it to Dr. Kutai, and he included it into the in the software so that I can use it. And this can be done for several other locations. I don't see why it cannot be done for an isothermal analysis. But to you, Dr. Kutai.
Yeah, absolutely. So that is the process, as you have already experienced. So all we ask is, right now you cannot do it by yourself. We didn't have that option because of, unfortunately, the complexity involved in having an user-defined climatic file. And I can get into the details of the complexity later on, but what we want you to do is, if you're interested in doing that, all you have to do is generate an HCD type file. It's a text file, the same format as typical MEPDG file, and send it to me. And of course, with latitude, longitude information as well. And I will add that as an option. So that's how it works right now.
That's great. That's great. Right now, the software runs with US units, but the international system of units is coming soon, hopefully, right, Dr. Kutai?
Yes, at some point we will do that. Right now, it's all US units. Yeah.
Okay, very good. And MEAPA does requires local calibration. This is not related to MEAPA only, it's the general MAPDG. There are material calibration coefficient, local calibration coefficients. So depending on the advancement of the analysis that you want to run, I guess you can have local calibration coefficients.
Okay, so that is a good answer. That's exactly right. But I'd like to add to that is that
Mm-hmm.
for bottom-up cracking, AC rutting, base rutting, CS subgrade rutting, IRI, thermal cracking, pretty much all except the top-down cracking model, the equations are identical to the original MEPDG documentation. And I'd like to emphasize original MEPDG documentation, NCHRP 137A documentation that is available on the website. It's the same equation. So if you already have a calibration done for your state, you can enter those numbers here and you should be fine. For top-down cracking, we have an improved top-down cracking model here. The same type of equation, except we are using the principal strains near the tire, not the Cartesian coordinate, but the principal directions. So that we show in Michigan data that is more accurate. So we're using that. So for that one, maybe there's a special calibration needed for your state, but for the rest, it's the same types of equations.
Okay, that's great. So I think we are running out of time, and I'm really sorry if I couldn't post all the questions that you asked, but I would like to mention that all the questions we received in the Q&A box are gonna be addressed in a blog of some sort, right, Dr. Kutai?
Yeah.
And we'll share all the responses with the attendees.
Yes, that's
Okay.
good. We want to keep the time right. We said 1 hour. It's exactly end of 1 hour. So I also apologize. We can answer all of them at the moment, but they will be answered in a blog. We will add a blog section in the MEPA site, and we'll put all that information. And also feel free to send a feedback question in the feedback if you are really interested in very quick answer. Just do that, and we will respond to that as soon as possible. Also, personal emails to me is fine.
Perfect, perfect. So I would like to thank again Dr. Kutai for this presentation and his valuable work on the MEAPA software. And thanks everybody, those who attended this session, and have a wonderful rest of your day. Goodbye.
Bye-bye. Thank you all.